All right, so exponent rules is the first one we're going to look at today. We're going to review over some exponent rules. Most of these rules you should already be familiar with. So here we go. First one, a to the n power times a to the n power. At this point, all of us know that when we're multiplying, the rule says we do what with the exponents? Add them. So in this case, it would be m plus n. Add up the exponents. So if we take a look at the few examples they give us there, the first one, 3 to the 4th power times 3 to the 5th power. Of course, I keep the base of 3. All I'm doing is adding the exponents. So what do you get when you add 4 plus 5? 9. So here we end up with 3 to the 9th power. The next one we have is x to the 7th times x to the 9th. Again, I keep the base. All I'm doing is adding the exponents. So 7 plus 9 would give us a 16. So we end up with x to the 16th power. And the last one, there's a little trickier here. We got b to the a power times b to the c power. Rule says I need to add up the exponents. So the question is, what do you get when you add an a plus a c? There it is. You get an a plus c. So this one would be b to the a plus c power. So let's take a look at that verbal description. It says to multiply terms. They have the same base. What are we going to do with the exponents when we're multiplying with the same base? Add the exponents. Which, like I said, this is a rule that you guys talked about back in Algebra 1. Nothing new there. Same thing on this second rule that we have here. At this point, we should all know that when we're dividing, what do we need to do with the exponents? Subtract. So here it's m minus n. We're subtracting the exponents. So if we look at the examples they've given us, we've got 4 to the 7th power divided by 4 squared. Of course, we would keep the base 4, and all we would do is subtract the exponents. So 7 minus 2 would give us a 5. So we end up with 4 to the 5th power. Same thing with the next one. X to the 17th power divided by x to the 21st power. If I subtract those exponents, what would I get? 17 minus 21. What's that? Negative 4. That is correct. However, if you were to leave that as your answer, it would be counted wrong. Anybody know why that would be counted wrong? There you go. Because we can't have a negative exponent. So does anybody remember how to fix it so that it's not a negative exponent? Yeah, put it over 1. So it'd be 1 over x to the positive 4th power. And we'll talk more about that rule here in a minute. But remember, you can't have a negative exponent. All right, so the verbal description. On this one, to divide terms that have the same base. Rather than adding the exponents, this time we're going to subtract. We're going to subtract the exponents. So when we multiply, we add. When we divide, we subtract. So those are the first two rules. Nothing new, you already knew that. Let's take a look at the next one. Here we have 2 exponents. We've got a to the n power to the n power. Anybody remember the rule for this one? What do we do with the exponents on this one? Multiply the exponents. So we would do m times n. We're multiplying this one. So if we look at the examples they've given us, we've got 3 to the 4th power to the 5th power. If I take those 2 exponents and multiply them together, we would end up with 3 to the what power? 20. 4 times 5 is 20. So 3 to the 20th power. Same thing with the next one. I keep the base and multiply the 2 exponents together. What do I get when I add those exponents together? Or not add them, multiply. 16. All right, so what do we get when we multiply those two together? Negative 16. But again, we run into that problem of having a negative exponent again, and we can't have that. So we're going to fix it real quick, and we'll rewrite it as 1 over 5 to the 16th power. So again, never leave your exponents negative. And the next one, x to the 7th to the 3rd power. If I multiply those two exponents together, I end up with a, what? 21. So all we're doing is multiplying the exponents. So over here on the verbal description, to raise a power to another power, as we just said, we're going to multiply the exponents. Multiplying the exponents. Again, this is a rule that you're already familiar with. The next rule we have here is a to the negative n power, which we've already seen on a couple of these examples. We just got through saying we cannot have a negative exponent. So what we do to fix it is we rewrite it as 1 over a to the positive n power. So if we look at the examples that they've given us, we've got 10 to the negative 5th. In order to have a positive exponent, we would just rewrite it as 1 over 10 to the positive 5th. The next example, 5 to the negative 1. How can I rewrite that so that I end up with a positive exponent? 1 over 5. Is it necessary that I put the 1? No. You could, but it's really not necessary. It's already understood to be there. X to the negative 7th. Again, if I fix that so that we don't have a negative exponent, it should look like this. 1 over x to the positive 7th power. So over there on the verbal description, negative exponents mean what? All we're really talking about here, guys, are reciprocals. Okay? Reciprocals. We're just taking what we have and flipping it upside down. That's what a reciprocal is. So up to this point, all these rules I've just gone over, you've already been familiar with. This next one, however, this is the one we just introduced yesterday. More specifically, we looked at what happens when we have 1/2 as our exponent, what happens when we have 1/3 as an exponent. But as we found out, really what we're looking at is the denominator, that bottom number. Okay? And what ends up happening is that bottom number represents our root. So it's going to look like this right here. A to the 1 over n power is equal to the nth root of a. So if you look at the examples they've given us, we've got 81 to the 1/2 power. Well, we said yesterday that that 1/2 exponent means the same thing as what? Square root. So that's the same thing as asking you for the square root of 81. Anybody know the square root of 81? No. So square root of 81 would be no. The next one there, 16 to the 1/4 power, would be the same thing as asking for the 4th roots of 16. 4th root of 16. That bottom number represents the root. Anybody know what the 4th root of 16 is? By the way, yesterday I think I showed you on your calculator, we know how to do square roots. I think yesterday I showed you how to do cube roots. Is that right? Okay. But can the calculator do 4th roots? Yes, it can. Let me show you here. Everybody get yourself a nice clean screen. And what I want you to do is type in the number 4 first. And that's going to be this right here, what we call the index number. Once you type in that 4, you're going to go to math like we did yesterday. Now, yesterday we used number 4. We're not going to use that one today. We're going to use number 5, I think it is. Number 5. And notice now it gives you the 4th roots, and we're looking for the 4th root of 16, so type in your 16. And what is the 4th root of 16? 2. So yes, your calculator can do 4th root, 5th root, 6th root, 7th root, 8th root. It really doesn't matter. You just type in the index number first, then go to math and select number 5. All right, we got one more here. X to the 1/5 power would be the same thing as the 5th root of x. And of course, we can't evaluate that because it's just an x. All right, so as far as the verbal description, The rational or the fraction exponent just means the root. It's just referring to the root. It could be square root, could be cube root, could be fourth root, fifth root, sixth root, seventh root. It all depends on what the bottom number is. So this is the one that we added yesterday. Most of you guys weren't familiar with that rule until we saw it yesterday. This next rule that I'm going to show you, you've probably never seen it before. This is totally new here. So we've got a to the m over n power. It's slightly different from the one we just talked about. Look closely here. This rule, we said, is a to the 1 over n. This next one that we're looking at says a to the m over n. Okay, so it's not a 1 for our numerator anymore. It could be any number. It could be a 3. It could be a 4. It could be a 5. So right here we've got two different ways that we can look at this. The bottom number still represents the root. So it's still going to be the nth root of a. The denominator in the fraction is going to represent our root. The top number is going to represent our power. In this case, n. So this is one way we can look at it. The nth root of a to the m power. However, there is an alternative way we can look at it, and that's this way. The nth root of a to the m power. Both of those mean the same thing. Now this one's real tricky, guys, so make sure you are following along really closely here. You're going to have an assignment on questions that look just like this. All right, so let's take a look at the first example. We got 81 to the, what is that, 3/2 power. 81 to the 3/2 power. So the bottom number in the fraction just represents the square root. So the first thing I wanted us to do is take the square root of the 81. The top number means the power, meaning we're going to take the power of whatever the square root of 81 is. By the way, anybody know what the square root of 81 is? 9. The square root of 81 is 9. But if I take this one step further, what is 9 to the 3rd power? What is 9 times 9 times 9? 729. So in other words, 81 to the 3/2 power would be equal to a 729. Everybody put that in your calculator for me real quick. 81, use your caret symbol like we did yesterday, caret symbol, and then type in your exponent 3/2, 3 over 2. And what you should end up with is 729. Okay. And how did they get that 729? Well, they took the square root of 81 first, then they cubed that 9. That's how they came up with that. Let's take a look at the next one, 16 to the 3/4 power. The bottom number, the 4, represents our root. So we're going to take the 4th root of 16. The top number represents our power. So the 4th root of 16. The 4th root of 16 is a 2. Because 2 times 2 times 2 times 2 would be a 16. However, we're going to take that number to the 3rd power. 2 to the 3rd power would be a what? 8. Therefore, 16 to the 3/4 power would be equal to a 8. And this is how we get it. All right, we got one more here. We got x to the 2/5 power. Again, this bottom number, the denominator, represents our roots. So here we're looking at the 5th root of x. The top number represents our power. In this case, that power is 2. So as far as your verbal description for our fraction exponents, the numerator is going to represent our power, and our denominator is going to represent our root. Top number is your power, bottom number is your root. Like I said, this is the one we're going to be working with quite a bit today. That rule we're going to use quite a bit. Now the next one, we're going to go ahead and introduce you to it, but tomorrow we'll look more in detail on this rule. Today we're just kind of introducing it. And this first, or this rule says that a to the n power equals a to the n power. If that's true, then the two exponents should be equal to each other. N should equal to m. If a to the n power is equal to a to the n power, And it should be true that the two exponents are equal to each other. So on this example they've given us over here, 5 to the 2x minus 1 power is equal to 5 to the 7th power. Well, if that's true, well then the two exponents should be equal. And then of course from there we could solve for x. But I'm going to save that for tomorrow. So don't worry about solving for x. We'll talk more about that tomorrow. The next one over here, now notice it's a little bit different. On this one, I can take the two exponents and set them equal to each other, and that's because the bases are the same. That's not quite the case we have over here. These bases are not the same. Here I've got a 9, here I got a 3. So I cannot just say that x minus 3 is equal to 4. Okay? And that's because this is a 9, this is a 3. We'll talk about what to do tomorrow. I don't want to get too far ahead, so we'll talk about that tomorrow. So over here it says you can solve for variables in the exponential equation if both sides have the same base. Gotta have the same base, which again we'll talk more in detail tomorrow. All right, so these are all the rules that we'll be using today, but really the biggest rule we'll be using is this one right here. So that takes care of the notes, guys. Now let's take a look at one of the assignments, and that's this one right here. Let's take a look at this one. Now make sure you have a calculator handy. Make sure you have a calculator handy. I'm going to help you out with some of these, and I'm going to have you guys do some on your own as well. So here we go. The first one, number 1, you'll notice it's got several parts. We've got A through H. So A, I think everybody knows what 9 squared is. What's 9 squared? Maybe I'm wrong here. What's 9 squared, guys? 81. There's your first answer. 81. B, 9 to the 3rd power. What is 9 to the 3rd power? 729. C, 9 to the negative 2 power. Are we allowed to have negative exponents? No. So what do we do to fix it so that it's not a negative exponent? 1 over 9 squared. Well, that's not quite the answer either, because I need to square the 9. And what do you get when you square the 9? 1 over 81. So our final answer for C should be 1 over 81. D, same thing. Can't have a negative exponent, so we rewrite it as 1 over 9 to the 3rd. And what do we get when we take 9 to the 3rd power? We get a 729. Now just real quick here before I move on, I want to point out something real quick. Notice A and C here. Notice the only difference in the problem is one has a positive exponent, the other has a negative exponent. What do we say the negative exponent is? What do we write down in the notes? Reciprocal. Well, isn't this right here the reciprocal of this? Yeah. Matter of fact, if you look at B and D, again, notice the only difference is one has a positive 3, the other has a negative. And we said that's the reciprocal. Well, isn't this the reciprocal of this? Yeah. So that's all it is, guys. That's all the negative sign is doing. It's giving us the reciprocal. All right, with that said, let's see if we can apply that with the next couple that we look at. E, we got 9 to the 1/2 power. Well, 1/2 power means the same thing as what? Square root. Anybody know what the square root of 9 is? 3. Square root of 9 is 3. Now, F is a little trickier here. We got 9 to the 3/2 power. So there's two things I'm going to have to do. The bottom number, this 2 right here, is telling me to take the square root of 9. That's what that 2 is telling me to do. The 3, your numerator, is the power. Raising it to the 3rd power. So let's see if we can do this. What is the square root of 9? 3. What if we take that 3 to the 3rd power? What's 3 times 3 times 3? 27. So the answer we end up with is 27. I want you to check something for me real quick. Run to your calculator. and I want you to type in 9 to the 3/2 power. Let's just double check, make sure we didn't make any mistakes. 9 to the 3/2 power. What number are you getting? 27. Again, I want you to see what the calculator is doing for you. It's taking the square root of 9, then taking that number to the 3rd power. Now, everybody look here. We're going to see if we can save ourselves some work. Look at E and G. What's the only difference between E and G? The negative. And what is that negative doing? Reciprocal. So, if we know E is 3, then we know G should be the reciprocal of that 3. And what's the reciprocal of 3? 1/3, 1 over 3. So save yourself some work here, guys. Same thing on F and H. Look at F and H. Notice the only difference between F and H is one has a positive exponent, the other has the negative exponent. So H over here is simply going to be the reciprocal of F. So what is the reciprocal of 27? 1 over 27. That's all the negative sign is doing. Just flip it. All right, I want to give you a chance to answer number 2 for me. A through H. See if you can do those on your own, and then we'll see how you did. I'll give you about 3 minutes, so don't waste time. Save yourself some time. Just look at the negative exponent and use the reciprocal of that positive exponent. All right, let's see how we're doing. A, 16 squared. What did you get for 16 squared? 256. So A is 256. Now notice the only difference between A and B is that B has a negative exponent. So all that means is that we're going to look at the reciprocal of 256. And the reciprocal of 256 would be 1 over 256. C, 16 to the 1/2 power. Well, 1/2 power means square root. So I'm asking for the square root of 16. And the square root of 16 is 4. D, 16 to the 3/2 power. Again, the bottom number represents the square root. The top number is the power. So the square root of 16 we already said was 4. So the next question is, what is 4 to the 3rd power? What is 4 times 4 times 4? 64. So the answer I'm looking for on D is 64. E, we got the 1/4. Therefore, we're looking for the 4th root of 16. And the 4th root of 16 should be a 2. 16, not 16, but F says 16 to the 3/4 power. So once again, we're taking the 4th root of 16 on to the 3rd power. So what did y'all get for F? What was the final answer? 8. That is correct. 8. So if I know F is 8, you'll notice that G, all it is the negative exponent. So all I'm looking for is the reciprocal of 8. And what is the reciprocal of 8? 1 over 8. And then the last one there, h16 to the 5/4 power. We're looking for the 4 root 16 to the 5th power. And what did you end up with? 32. So the answer there should be 32. All right, let's move on to the next section. Simplify by writing each as a single expression. So here we're going to go back to the rules that we talked about. First rule is division. What are we supposed to do with the exponents when we're dividing? Subtract. So use your calculators here, and let's subtract 1.5 minus 0.9. 0.6. That is correct. So we end up with a to the 0.6 power. Let's try B. 63 divided by 9. What's 63 divided by 9? 7. Now I'm looking at the x's. I need to subtract the exponents on the x's. What do you get when you subtract 9 over 2 minus 7 over 2? Come on, 9 over 2 minus 7 over 2. 2 over 2. And what is 2 over 2? So 1. The y's. Look at the exponents. We got 7 over 2 minus 3 over 2. What's 7 over 2 minus 3 over 2? What? 4 over 2. However, what is 4 over 2? 4 divided by 2 is a 2. So we end up with y squared. All right, C. 2 over 8. 2 over 8 can be reduced to 1/4. M. Look at the exponents and let's subtract those exponents. What do you get when you subtract 11/4 minus 3/4? 8/4. However, 8 divided by 4 would leave you with a 2. So we end up with m squared. Do the same thing with D. Subtract the exponents. 3/4 minus 7/4. What's 3/4 minus 7/4? What's that? Negative 4 over 4, which is the same thing as negative 1. But remember, we can't have a negative exponent, so I'll fix that by putting our D down here at the bottom. So we end up with m squared over 4D. Okay, next section. This time the rule we're going to use is multiply the two exponents. So I'm going to have 1.5 times 5. What is 1.5 times 5? 7.5. Let's keep going. B. Look at the x. Let's subtract, not subtract, but multiply the exponents. 1/2 times 8. 1/2 times 8 is a what? 4. Do the same thing for your y's. Multiply the exponents. 3/4 times an 8. What is 3/4 times an 8? 6. So we end up with x to the 4th, y to the 6th. See, a little tricky here. Let me go ahead and start over here. I'm going to multiply the exponents. 1/2 times the 5. 1/2 times the 5. What is 1/2 times the 5? What? No, not 0.5. 2.5. But I'm going to write that as a fraction. That would be 5 over 2. Same thing. Now be careful on this one. Notice how the 9 is inside the parentheses. So that 1/2, I need to make sure I use that exponent on the 9. So anybody know what 9 to the 1/2 power is? 9 to the 1/2 power. 3. Remember we said 1/2 power is the same thing as square root. Now look at the end. We're going to multiply the exponent. 6 times 1/2. What is 6 times 1/2? 6 times 1/2. 3. We're almost done. Let's multiply these two things together here. 4 times 3. 4 times 3 would give me a 12. Since I'm multiplying, I need to add up those exponents. What do you get when you add 5 over 2 plus 3? 5 over 2 plus 3. But give me the fraction. 11 over 2. That is correct. So we end up with 12m to the 11 over 2 power. All right, next section here, all we're doing is rewriting. So, for example, A we're given 7 to the 1/2 power. Well, 7 to the 1/2 power is the same thing as the square root of 7. That exponent 1/2 means the same thing as square root. On B, it's just the opposite. They give me the power or root. I want to write it as an exponential. I want an exponent. What is my fraction that I'm going to use as my exponent? 3 over 5 or 5 over 3? 5 over 3. The bottom number is always that thing right there. C, e to the negative 3/4 power. Well, first of all, that is a negative exponent, so I'm going to change that real quick and write it like this. No more negative exponent. But I want it in the form of a root and a power. So here we go. The bottom number represents the roots. The top number represents the power. So there it is. I want you to try D, E, and F for it. D, E, and F. Remember, all we're doing is rewriting them. There's nothing to evaluate here. Letter D, you should not be putting in your calculator. We are just rewriting them. All right, let's see how we're doing. D, 3 to the 1/3 power. Yesterday we said anytime we see the exponent 1/3, it means the same thing as what? Not square root, cube root. So this is the same thing as the cube root of 3. That's what I want to see. You didn't have to solve anything, you just rewrite it. E, we have m to the 9/5 power. The bottom number represents our root, so we're talking the 5th root of m. The top number represents our power, in this case, 9. And F, we're going to have C. Now notice it's a reciprocal here, so it's going to be a negative. The question, negative what? 3 over 7 or 7 over 3? 7 over 3. The bottom number is always our index. It's our root. All right, let's finish up the last part here. Let's go back to our rules. First one here, we're multiplying, so we're going to add up the exponents. So we got 1/2 plus 3/4. Put that in your calculator. 1/2 plus 3/4. Okay, but I want the fraction. Use your math. 5 over 4. So I've just simplified the expression. However, they ask us to write the final answer involving roots and powers. So instead of leaving my answer like this, I'm going to write them in the form of roots and powers. So we're going to use the 4th root of x to the 5th power. That's how they want us to write the answer. Let's do the same thing with this next one here. Let's add up the exponents and let's see what we get. 0.45 plus 0.3. Samantha, what do you get when you add 0.45 plus 0.3? Okay, but give me the fraction. Use your math button to give me the fraction. Three-fourths, 3 over 4. However, we're not going to leave the answer like that. And that's because we're going to use the roots and powers. All right, so how do I write this? This would be the 4th root of m to the 3rd power. Again, the bottom number is our roots, top number is our power. And the last one here, notice this time we are dividing, so let's make sure we're subtracting the exponents. So 1/3 minus 3/4. 1/3 minus 3/4. What do we get when we subtract those exponents? Make sure you give me the fraction. -5/12. But I don't want to write the answer like that. I want to write it in the form of a root and a power. Now notice it is a negative exponent, so we're going to write it 1 over what? 12th root of x all to the 5th power. That's what it's going to look like. All right, any questions on any of those? Good. All right, so I've done one of your assignments with you.